Now that I have been at this for 4 years, I'm beginning to have a lot more thinking about what I call the L of learning. So you can either go broad. So this is kind of like your base. Okay, this is sort of like your base, and then this is really how much you want to or need to specialize. All right, so I'll go through these very quickly just to show you. So I have done number theory, some. I mean, when I say done, I mean like I did some. All right, real and complex analysis, linear algebra, and now I'm not halfway through Gaussian, so it shouldn't be like a full check mark, but if it was like a little bar, this is done, and this is kind of like here. And then I have a choice since I still have a linear model. Uh, the considerations that I'm having is, do I broaden my base? Okay, do I broaden my base to a bunch of topology, some combinatorics, ODE, PDEs? There's more to broaden my base with, but I think beyond this, I would consider it pretty broad. Or do I continue along algebra, with which I'm having a lot of fun? Uh, Maybe pick up some algebraic and analytic number theory. Eventually, at some point, do some functional analysis. But this is really specialization. And when you get down to what people do in academic programs, you do an L. All right. In your bachelor's, you're in this part of the L, and you never really go further down. Maybe in your senior year, if you really liked abstract algebra, you take like a third semester, and it's Galois theory, like specialized Galois theory. You could really like graph theory and take like a graduate level course in graph theory, maybe one or two. People do that, and I did that in electrical engineering. I think it was 2 graduate level courses in my senior year. But you're really roughly here, and maybe you'll do a little dip. But then once you get into a PhD program, you're going to hit parts of your base harder because you're going to need to do qualifying exams. But you may not do a qualifying exam. I doubt most people do on ODE, PDE. So if you took some differential equations in your bachelor's in math because you liked applied math, you may never get to see them again if you don't specialize in them in your PhD program. Now, the academic programs, rightfully so. I mean, they have to do this. They need you on this narrow band to the PhD as soon as possible. So you're going to do your graduate level coursework, which is not as broad as your bachelor's coursework, but as soon as possible, you're going to go down a very narrow lane to hit something new at the edge of knowledge, which is really where somebody will say, well, we'll give you a PhD. Nobody's really worked on those details like that before. But in my case, since I'm a hobbyist, it really is bound to time, and this is more like to anybody who's a hobbyist. This is really what the discussion is about in my mind. And so, I have considered an option of, I have things that are in my base, and then things that are specializations. If I want to continue doing more and more abstract algebra stuff, some homological algebra, commutative algebra, eventually algebraic geometry, which of course has so many prerequisites. So really, it's always going to be a specialized course. I've also considered the option of doing this, right? So doing a subject that is in my base. So say maybe after linear algebra, after algebra, going to combinatorics. So maybe do combinatorics here, and then come back to specialization and do commutative algebra. Then after that, get out and then do some functional analysis in my base, right here, and then come back and do algebraic geometry. That is an option. I don't really know which way I'm going to go, but I just wanted to lay it out as just to let you know, this is what I've been thinking about for the last 3 months, 4 months. I've been thinking about making these diagrams and thinking about them, and I just wanted to share them.